This week our lecture is on Agile software development, and so therefore we are no longer in the textbook. There's no accompanying textbook material for this course on Agile software. This is one of the things I think is a little bit of a weak point in the textbook, although I think if you were to try and add and integrate Agile software development into the textbook as it is, it would end up being quite a Herculean effort and possibly not do a very good way of, may not actually be all that good in terms of introducing either traditional approaches or Agile software. So it makes sense to have other references for this sort of thing. And I will give you quite a few recommendations and references over the course of this week's lecture. Here's a very quick overview of what we're hoping to cover. Essentially, where did these things come from? What is the history behind Agile methods? What are they? Can you give some examples of like what constitutes the high-level principles of Agile software development? And then we're going to walk through in a little bit of detail extreme programming, a little bit more detail on Scrum, and then I'll talk about lean software and Kanban and some of the things that have kind of become like post-Agile inspired additions to iterative software development. But first, we're going to start with the main motivation behind Agile, and that is risk. Customers don't know what they want, and customers not knowing what they want tends to drive lots of other risks, including changing requirements. Software development is primarily challenging because requirements are very difficult to pin down in a definitive fashion at any point in the development process, right up until you release the product. And that is an unchangeable law of software. It just seems to be the way software development happens. It actually, I think, in some ways is the way physical development happens. If you've ever watched someone struggle to build a house, there's always one or two things you'd like differently, and it ends up becoming something you just tweak endlessly over the course of the time that you're in the house. But with software, there's a little bit more of a sense that you could change literally anything in the project because it's software and you're not limited by physical constraints. All right, so here's a little bit of an abbreviated history for software development in general, to kind of give you a sense of how different Agile methods were and how young they are compared to a lot of the other stuff that we've had for software development for a long time. In the 50s and 60s, we did actually have software. There were computers, but they were primarily very large systems for very large companies. Each one was managed using a totally unique process, lots of custom solutions, right up until the waterfall was introduced in roughly 1970, and then we started moving to contract systems because the waterfall model encourages you to define everything up front and then use a process to achieve that over the course of some particular time period. And this worked reasonably well for some organizations. I think mostly because we were still building essentially large systems for large companies at that point. Waterfall was not a bad way of doing this sort of thing. But as personal computers were introduced in the late 70s, early 80s, people started doing more end-user type programming, homegrown programming solutions. And at this point, I think we have our first sense of where we might need Agile methods. Because the waterfall model for most of the 70s was seen as a good thing, but in the late 70s, early 80s, when we started seeing more one-off systems being developed, it started breaking down in places, and it was pejoratively referred to as the mushroom model of software development. Because the idea behind it was that you would keep the job of the manager of a waterfall software process was to keep the engineers who were actually building the system in the dark and feed them, poop, for lack of a better word. And the idea behind that was they shouldn't be worried about all of the requirements or all of the upper management stuff. They just need to build the thing that we want them to build. And so with no notion of how it connects to the larger picture. And so that's problematic when you start building these smaller, intricate systems that change more regularly. Because of this, the spiral model and incremental iterative models were developed in the mid-'80s. I think this is really the point where CMMI starts taking off too, mainly because we want to see like what is the process and how good are we at following the process, and can we measure this in some sort of a way that would be consistent. And then through the 90s, we start seeing networked applications, internet applications, and much like the the strain that the development of the personal computer put on this waterfall model, the networked applications, also seemed to strain it in a way that was very, very difficult to quantify. And so in roughly the year 2000, Agile methods were introduced, the Agile Manifesto was published, and the idea behind it was we want smaller systems for smaller companies, and we want evergreen software, meaning we're not just trying to release a single product that sits on a shelf and is shrink wrapped and someone buys it and uses it as is, but something that can be updated over the network and possibly have major features added after the initial release over time, right? This notion of having an evergreen version of, Firefox or Google Chrome or whatever web browser you're using. So that was the idea behind each of the major developments in software. I think this is a good point to recommend The Soul of a New Machine by Tracy Kidder. This is a book written about that inflection point in the late 70s where all of a sudden we start seeing the problems with the waterfall model. The mushroom model, in fact, was a term that was coined by some of the engineers who were profiled in this book. And I would just say in general that you owe it to yourself to understand a little bit of the history of software development if you're going to work in this industry. Way too many mistakes end up getting repeated over and over and over again. I think you could pick up The Soul of a New Machine and find problems that are just evergreen. We're always going to have these sorts of managerial issues. And some of these challenges are maybe specific to software development, but they are timeless in the sense that we keep seeing them regardless of what process you're using. It's also interesting to see some of the things that don't actually happen anymore, right? Because you learn a little bit there as well. What challenges last and are timeless, and what challenges don't last and are really kind of ephemeral products of history. Very, very good book. Excellent, well-written book. Strongly recommend this one. Okay, so another way to think about software development is, okay, what happens when it fails, right? And if you have a software engineering process that's essentially this column, and you have common sense, you're probably not going to fail. You're probably going to get quality software at the end of the day. If you have a software process and there is no common sense or no room to adjust to obvious problems, then you end up with mindless bureaucracy, people who are just following the process for the sake of the process, even if that does not actually make sense in terms of building a useful product. If you do not have a software engineering process, but the team has a lot of experience and is world-weary and has a lot of common sense, then you might actually do something better than quality. You might have some truly creative chaos where you'd be able to create something that would be better than you could ever have planned it, right? So this could be really, really good, but most of the time you're not going to end up with quality. You're going to end up with something that is at best a prototype that has some show-stopping flaws or cannot be used at scale or what have you. That's essentially this creative chaos issue that you're running into here. But if you don't have a process and you have a lot of neophytes, people who are not experienced in software development, you will end up with mindless chaos. And this will look very similar to creative chaos. So a lot of people who are claiming, well, software process is silly, we don't need waterfall, we don't need agile, we don't need structure, they're the people who are probably in this category. Most of the time they're going to be somewhere here in this mindless chaos bucket. And way too many projects end up actually falling into the mindless bureaucracy bucket as well, in the sense that the managers who don't have experience will just default to saying, let's do this thing because it's the thing the process wants us to do. Okay, and that is primarily an issue with waterfall software development, especially when you have managers in the process who have not actually been on the front lines as engineers because they never gained that experience or the sort of common wisdom of an engineer. They're just following a process. So these two problems are really the issue that Agile software development is trying to cure. They still want a process. It is actually a process, but we want to make sure that we're not sacrificing common sense to get to that process. Okay, so that's everything I have for this section, and in the next section of slides we will be going over a little bit more history to talk about Agile methods in particular rather than just where they came from.